Hello, everyone. My name is Chandra Nelogal. I work as a DMTS at Dell Technologies, focusing on storage solutions and security. And with me, we have Joseph Chen, who is the CEO of Yuling Technologies. And we are here to represent the Trusted Computing Group's storage work group for our session. Let me start with a presentation. As I said, between Joseph and I, we will be covering the update of the storage work group within the TCG, and we'll get started. Here is our agenda for the session. We're going to cover some introduction. We'll cover the learning objectives. We'll cover the status update of different standards documents that are in progress with the storage work group. We'll cover some of upcoming plans, and we'll also refer you to some other sessions related to this. In terms of the introduction, the Trusted Computing Group, or the TCG, is a very big industry standards organization. It has several focus areas such as attestation, cloud, networking and communications, PCs, server, storage, vehicle and automotive technologies, IoT, mobile devices, virtualization platforms, etc. So it is a very wide participation from device manufacturers, silicon manufacturers, solution provide vendors, cloud service providers, and government agencies. For more information, please refer to trustedcomputinggroup.org. The storage work group, which is part of the Trusted Computing Group, focuses on security features specific to storage devices and solutions. Some of the familiar or more popular documents that you may be familiar with, such as the TCG Enterprise SSC, TCG Opal SSC, TCG Ruby SSC, and the Pirate SSC, are all from this work group. In addition to the different SSC documents, the storage work group also works on storage interface interaction specification called SIIS, which covers the interaction between the different TCG protocols and the different storage command sets, such as the ATA command set, NVMe command set, and SCSI command set. In addition to the SSCs and the SIIS documents, the storage work group also works on different features such as configurable namespace locking, configurable pins, block SID, various other features and test related documents, certification related documentation, application notes as applicable, which will be covered a little bit later in the presentation. Going on to the learning objectives. So the main learning objective for us for this session are for you to get an overview of the current activities with respect to the standards that are happening at the storage work group, get a preview of the upcoming standards activities, again in the storage work group, understand some of the trends in security related to storage, which should help you ideally to plan for your storage security feature set and capabilities in your different products and solutions. We also welcome your participation and input in the storage work group focused on security. With that, let me cover some of the core specification, SSC and SIIS status, and Joseph will cover a few things a little bit later. So I'll be covering some of the SSCs, as I said, the Enterprise SSC, Opal, Pirate, Ruby, Keeper IO, and some of the interface document status. So in terms of the status of the different subsystem class, security subsystem class documents, the core specification was last updated in 2015, and currently we are not tracking any outstanding items for this specification. Similarly, the TCG Enterprise SSC was last released and updated in 2015, and currently we are not tracking any outstanding items for update for this specification. The Opal SSC, the last one was released again in 2015, and currently the 2.02 version just completed its public review on September 5th, and we have some comments that we received, and we are working through that comments right now. And some of the major changes from the previous version are we are providing additional reset mechanism, mainly the hardware reset mechanism, in addition to the power cycle and programmatic reset mechanism. We are representing the estimated time value in a level 0 discovery for long operations such as change of the media encryption key, revert, or the revert SP operation. For the manufactured SP, the manufactured inactive state is now marked as a mandatorily supported state. And also the block SID feature set is now marked as a mandatory feature set for the Opal 2.02. There are several other changes in the document you will notice, and many of them are editorial and complying it to the new format of the documents as per the technical committee and the TCG guidelines. The Ruby SSC was last released in January of 2020, and currently there are no items being tracked for update to this SSC at this time. And similarly, the Pirate SSC was last released in May of 2020, and currently we're not tracking any outstanding items for this. Going on to the next SSC, the Keeper IO is actively under development. We from the storage work group are working in close connection with the NVMe work group and also with the OASIS KMIP committee for definition of this SSC. There is a separate session focused on KPIO presented by the same work group by different representatives. Please attend that session or listen to it for more details about this. Going on to the status of the storage interface interaction specification. This document, as we said, right, it covers the interaction between the different command sets and the storage security protocols. The previous version of the SIIS, which is 1.09 version, was released in December of 2020, and currently the 1.10 just completed its public review on September 5th, and we are working through some of the comments that were received as part of the public review. Some of the major changes I'm going to touch upon from the previous version are that we introduced a SIS feature descriptor. Currently, it carries just a single, valid information piece, which is just a flag to indicate the behavior of the write pointer when a cryptographic operation is performed on a zoned namespace device, whether the write pointers remain where they are or they get reset. That behavior is determined by this, expressed by this flag, which can be read in the feature descriptor. And many of the other changes in the SIS document are all focused on NVMe. As you can imagine, as the NVMe standards evolve and their new command set are added, the storage work group looks at it, reacts to it, and tries to align the storage security feature set along with the command set. So some other changes are now the subsystem can be reset through the NVMe MI interface, the security subsystem that is. If the namespace is write protected, then whether it is write protected on a permanent basis or just till the next power cycle, then the TCG methods that map to that namespace will not work, will fail. The compare and the verify commands, similarly, right, if the LBA range upon which the compare and verify commands are read locked, then the compare and the verify commands will fail. And the copy command, if the source LBA range upon which the copy command is acted upon, if that is read locked, or if the destination LBA range is write locked, then the copy command will fail. These points are made clear in the 1.10 version of the SIS document, and that is just completed public review, as I said earlier. Some of the items we are working through for SIS 1.11 are NVDIM N command set, some of the clarifications related to sanitize and the format NVM cleanup work, some of the interactions with the firmware update mechanisms, and some other items as they are brought up by the member organizations. Just a note, the SIS 1.11, we don't have a draft specification yet, nor is the scope of it is finalized at this time, but these are just preview of what may come into the scope of it. With that, let me turn over to Joseph for the next part of the presentation. Thank you.
Thank you, Chandra. Welcome to the SDC 2021. My name is Joseph Chen. I'm with Uling Technology, and I represent with Chandra for the storage work group in the TCG to give you some updates on the storage work group recent activities. And in my part, I will cover two areas. One is new features that we are providing and plan to provide. And the second part is the testing. So those are the two areas that we're going to be discussed later today. Next. So the first feature I want to explain to you is the Brexit authentication updates. The Brexit authentication was published in few years ago at the 2015 at the version 1.00. The purpose for the Brexit authentication is to prevent the drive being taken ownership and used by the malware or attacked. By definition, the drive before it taking ownership, the SID or SID or PIN is same as MSID or non-characters. So before the drive has been initialized or taken ownership, the SID can be hijacked and changed. So storage work group defined the Brexit authentication to prevent this kind of event by a capability to block the SID to be altered or changed after this is enabled. Recently, we found out another potential issue is we are seeing some potential issue on SID to be or the authority to be changed, and so we are defining a new feature called freeze lock. The locking SP freeze lock is similar to ATA freeze lock state or operation. That when the freeze lock is set, the security state cannot be changed, and this is to prevent any malware to change the security state. They define a new life cycle called manufacturer frozen, and this is a new life cycle interchange with the manufactured and manufacturer frozen, those two states. So this when the device enter the manufacturer frozen state, the security information cannot be changed, and this will protect any further attack by other malware or the virus. Next. Now I'm going to give you another update on configurable namespace locking feature set. Configurable namespace locking object is defined for the NVMe device, because NVMe device was is currently supporting multiple namespaces capabilities. You can have from 1 to number of namespaces on one device. And because of that, the storage workgroup has defined this locking object to cover multiple namespace. So namespace can be a independent space, LBA from 0 to the max. Each namespace has its own LBA range. By 2019, storage workgroup published the initial spec called version 1.00. And this spec defined several new locking objects. The two new locking objects that was defined is namespace global range locking object, and the other object is namespace non-global range locking object. With these two objects, we will be able to define the namespace on how do you lock in each namespace or multiple namespace with a locking object. And that was defined initially for the NVMe. Later, we defined the application note to describe how this locking object been initiated, been used, and been removed. And so this is a application note that published last year to describe the use of the CNL. Later, we have come up with a realization that the SCSI or SIIS also has a concept of similar to the LBA range, LBA mapping in namespace. In SCSI, they call LUN or logical unit number. And this LUN can be also used as configurable locking object. So we publish, not publish, but we are working on publishing this version 1.01 that is currently finishing up the public review and almost going to be published in the public in the next near future. And this one basically use the same concept of NVMe namespace to map into SCSI. And because of that, the name of the specification has changed to configurable locking for NVMe namespace and SCSI LUNs rather than configurable namespace locking. So you can see it's CL versus CNL. In addition, we also found out this a need to describe the single user mode more closely because the single user mode in the namespace also be able to map into a single user mode range. And we added certain support for the security for the single namespace. And I'm going to describe one by one from here. Next step, next slide. So here is the high-level description of the configurable namespace usage. In an NVMe namespace on the left side, initially you have a global locking object and multiple namespace. Using the set and method, you can configure this device to have multiple locking objects under single namespace. So you can set to that and set it back to remove it. In addition, we also define assign and deassign method to map the global locking object to a multiple locking object and multiple namespace. That means that each locking object can be can have several namespace or single namespace in combination, and you can have multiple namespaces there. So that is for the NVMe. For the SCSI, because we don't have to cover the the single namespace, because SCSI long usually define several longs, so we don't need the set on the left side. We just do a assign and deassign, similar to the right side of the NVMe. So that's basically a assign and deassign method for SCSI longs. Next slide, please. So in the configurable locking object, we define as two main locking objects. So initially, the device is under the global locking object. So that is initial stage before any configurable namespace is being used. And the assign method would take the global range locking object to namespace global range locking object. That means that you can assign certain namespace to the namespace global range, and that is single. That is just one global, everything for that namespace global. Now you can then do a second level of assign to assign the namespace to non-global range locking object, and this could be many of them. You can have assign several namespace to the locking non-global range locking object, and so that is the level of assignment from global to non-global, and then you can be assigned to global before you return that range to the global range. So that's a structure of how you configure the locking object in the CNL. Next. On the single user mode, SUM, there's a need to make sure when you assign the single user mode range, you have to make sure the key on that namespace originally in the global range should be changed, and the data will be erased. So it defines clearly during the assign of namespace. For example, in this picture, NS1 key, when they assign the NS1 to a single user mode range, the key will be changed and it will have a new key. And as a result, those data will be erased. And when you want to return a single user mode range to the global range, then the single user mode range 1 NS1 key will be removed and during the deassign, and then going back to the global range. That means that the data in that single user mode range 1 will be erased. And by defining this, you guarantee that the data, when you assign to a single user mode or deassign from the single user mode, securely erased to protect the data from being misused. Okay, that's in the proposal. The proposal is in version 1.02. Currently in the process of making it to the public review. Next. Next feature I want to talk about is the shadow MBR for multiple namespaces. As the shadow MBR being used, shadow master boot record is normally used for PVA or pre-boot authentication. Now, the shadow MBR before was defined for just single namespace or single use for certain names, certain device before the namespace was introduced. Now, because NVMe has defined multiple namespace, so this shadow MBR for multiple namespace version 1.0 was published on October of 2020. The purpose of this shadow MBR for multiple namespace was to define which shadow MBR is associated with which namespace. The namespace can define certain specific namespace that is associated with the shadow MBR, and also it can do a every namespace is associated. So when the default value could be either 0 or OF or existing namespace, and when the OF is there, then this shadow MBR is representing for every namespace. If it's for an existing namespace, then this shadow MBR only associated with single namespace. So that is the definition to allow the shadow MBR to associate with all or specific namespace. Okay, and so there's a rule defined for MBR control NSID, and this MBR control MSID defined that if it's defined for all of them, then you will have a OF. But if you have a specific namespace, then this will be a specific namespace MBR control. Okay, so that's just for the shadow MBR. Okay, next. There are a few more features that the storage workgroup is introducing. The first one is a CPIN enhancement. And this, by the way, are new features, and we invite all of you to participate and contribute and suggest your ideas. The first one is configurable CPIN Trylimit per authority. So CPIN usually is a credential or password. They have a number of try that is currently defined by the manufacturers, like 5 times or 10 times try limit. After this try limit, you have to do power cycle to restart it again. The configurable CPIN try limit is allowing the authority to change number of try limit so that you can have a new try limit. For example, if you want to tighten your security, you can have 2, 1, or you can have more try limit to allow more flexibilities. And this is defined in a configurable CPIN try limit. In addition, we have a persistence. So the persistence is allowing the user to limit the total try. So even if you power off the drive, the try is remembered or persistent over the power cycle. So this allows the security to be set more higher level. And we also describe minima and maxima pin lengths. The second feature we are doing is CPIN force pin change. So before the pin was defined, all this authority has a no string to define the pin, or not defined. Okay, and in current spec, we want to have a protection. So anytime you try to use this authority, the device has an option to set the force pin change. So you have to change the pin before you can use. And before you change the pin, you only can do a random or set method to change the pin. So this will allow the protection from this pin to be, user to be used, and no pin to change other authorities or the securities. And this is also under discussions for the force pin change. Next. So next, currently there is storage test and certification program. The purpose for the test and certification is to make sure the device that conform to this SWG specification can be interoperated with each other. And in addition, we will have a security evaluation to make sure the devices also conform to the security. So Storage Workgroup has defined the test cases specification for Opal family that was published in April 2019. This test cases specification covers Opal family products such as Opal, Pyra, and Ruby SSC. And the program to perform the test and the requirement to get the certification was published in August 2020. The requirement for this is you have to complete the compliance test, and then you also need to go through the security evaluation. After that, you have the certification on the TCG website. And certification is provided for the TCG member only. We also define the test houses and the test suite to perform this compliance test. And this test house and test suite will have to submit, the test suite has to be submitted and approved by the TCG Storage Workgroup. And currently, U-Link is the approved test house, and the Opal SSC test suite 4.0 is the approved test suite. So these are the tests and the certification that is to promote the TCG storage device to be understand and securely and interoperable with other devices. Okay, next step. Like Chandra has mentioned, we have Keeper IO presentation separate from our current status update because it's more involved and more detailed. Keeper IO is a new feature, and we welcome all of you to join the this separate session in this storage developer conference, and that will have a little bit more, much more detailed information on what we are doing on this KPIO, and also you can also participate and contribute to this effort. That's conclude my presentation, and thank you for your attention. Thank you.
Thank you all.